The previous Hubness-aware classifiers tried to increase classification accuracy by taking into account that some bad hubs may be present in the data. Next, we will consider the task of classification from a slightly different perspective. We assume that the classification task can be solved with sufficient accuracy. However, we focus on solving the classification problem as quickly as possible. That is, we want to speed up the classification of new instances. There are various speed-up techniques for nearest neighbor classification. Some of them may be based on calculating the distance or similarity measure efficiently. Some other speed-up techniques may be based on indexing. Here, we will only focus on instance selection, and I will argue that it is important to take the phenomenon of hubness into account while selecting instances. In order to understand instance selection, let us first review how nearest neighbor classifiers work. In order to classify a new instance, we have to calculate its nearest neighbors. And in order to calculate the nearest neighbors of a new instance, usually this new instance is compared to all the instances of the training dataset. And this may be computationally expensive, especially if we work with time series or other kind of complex data, in case of which the calculation of the similarity or distance measure is computationally expensive itself. So the idea is to select a subset of the training data, and instead of calculating the similarity or distance of the new instance to all the instances of the training data, we will only calculate the similarity or distance of the new instance to those selected few instances. In case of big datasets, this may substantially reduce the classification time. For example, if the training data has millions of instances and we only select 5% of them, it takes substantially less computational time to calculate the distance to those selected few instances instead of calculating the distance to all of the millions of instances. After considering this problem from a theoretical point of view, it turns out that finding the optimal selection of instances is NP-hard in general. Without talking much about algorithm theory and without properly defining what it means that a problem is NP-hard, I would just like to tell you that in terms of simple language, in terms of our everyday language, it means that this problem is quite difficult to solve, although it is not completely impossible. However, it is quite difficult to solve, especially for big data sets. Interestingly, a simple solution gives surprisingly good results. In particular, if we rank instances according to their good hubness scores and we simply select the top ranked instances, then the results are surprisingly good. The details are described in the paper referenced on this slide. More interestingly, instance selection may also reduce noise, and therefore it may not only speed up classification, but it may also contribute to more accurate classification. Furthermore, you may have wondered if instance selection can be combined with those Hubness-aware classifiers that we studied at the beginning of this lecture. And the answer is, of course, yes. However, when these Hubness-aware classifiers are used together with instance selection, it is worth to calculate Hubness parameters such as NKX, GNKX, PNKX, or NKCX on the entire training dataset, while we can use the selected instances for classifying new instances so that we can speed up the classification of new instances.